Sir, give the absentee list, please, for both the session.
Okay. Roll number 27.
Yes, sir.
मैम ऑलरेडी आप को होस्ट है। हाँ, आप भी को होस्ट है और 28 भी को होस्ट है। जब कुछ क्वेरी आती है सर की तो आप उस पे आपका माइक अनम्यूट करके आप बोल सकते हैं, क्योंकि क्या होता है कि अभी मैक्सिमम पार्टिसिपेंट का माइक अनम्यूट होता है ऑलरेडी।
Okay.
हाँ, तो आप और 28 दोनों का
8 नंबर।
ये रहेगा कि उसमें बस देखना है, बस सर का कुछ क्यूरी रहता है तो आप उनको बोलिए बस।
ठीक है सर।
सर एक चीज जाननी थी।
रोल नंबर 27 मैम, तुमचा माइक अनम्यूट कराइए। ओके,
हाँ, yes.
Welcome, Panaskar, sir.
Good afternoon, sir.
Hello.
Thank you.
Welcome, sir. Good afternoon.
Good afternoon.
आवाज येतोय ना
Sir.
माझा?
हाँ. Yes, sir.
येतोय
Yes,
sir,
sir.
येतोय.
Okay.
हाँ.
Sir, can
Please
I
start
start?
the introduction of the guest.
Okay, sir.
Yeah,
Good
yeah.
afternoon, all of you, and welcome to afternoon session of refresher course in disaster management. Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar, UGC-MMTTC. I am Dr. Pallavi Bhavsar, Assistant Professor of Economics at Mahila Kala Mahavidyalaya, Chhatrapati Sambhajinagar. It is my absolute pleasure to introduce today's respected resource person, and I am delighted to share the impressive biodata of today's renowned and visionary person, Professor Dr.Dipak Baburao Panaskar. Today's esteemed speaker is Professor Dr. Dipak Baburao Panaskar. He is a distinguished geologist, academician, and administrator with an extensive career spanning over 34 years in teaching and 24 years in administrative service. Dr. Panaskar has held prestigious positions, including senior professor and former director of the School of Earth Sciences at Swami Ramananda Tirtha Marathwada University, Nanded. With expertise in environmental geology, geochemistry, remote sensing, and GIS, he has made remarkable contribution to research, curriculum development, and academic policies. He has also served as in-charge Vice Chancellor, Dean of the Science Faculty, and member of the Academic Council, playing crucial role in higher education reforms. A recipient of numerous accolades, including the Ideal Teacher State Puraskar, Government of Maharashtra in 1913, and the Indira Gandhi Excellence Award 2013, Rashtriya Gaurav Award, the Best Citizen of India Award 2012, Best Teacher Award 2010 and 11. Dr. Panaskar has significantly contributed to implementing NAC accreditation, CBCS and CGPA systems, and NEP 2020 reforms. He has represented India in various national and international conferences in the UK, USA, Thailand, Tunisia, and Egypt. Currently, he serves as a visiting fellow consultant at the Ministry of Earth Sciences, Government of India. Sir's guidance on research work is as follows. PhD degree awarded 17 students, MPhil degree awarded 5 students, MSc degree awarded project 120 students, PG diploma degree awarded 2 student project. Sir's research published total 79 in international 35, national 40, regional 4, citation 2097, index 22, I-10 index 36. Sir, it is an honor to have him with us today. Let us warmly welcome Professor Dr. Dipak Baburao Panaskar. Sir, we respectfully requested that you graciously share your expertise and enlighten us with your thoughts. Welcome, sir. Over to you, sir.
Thank you very much for nice introduction. Now I will share the PPT.
सगळीकडे. हॅलो,
शेअर होत नाही PPT.
स्क्रीन शेअर होत नाही का सर?
हा, एंटायर स्क्रीन करू का?
हा, तुम्हीच शेअर करायची सर स्क्रीन.
हा, मीच शेअर करतोय.
एकदा ट्राय करा, नाही तर मग इकडे पाठवा. मी इकडे हे ना शेअर.
कारण ओपन केली PPT आणि मिनिमाइज केली.
गौरव, हॅलो. हॅलो. चालेल. हो.
दिसत आहे का पीपीटी?
हा ओके सर.
ओके ना?
हा फक्त त्याला डिस्प्ले मोड प्रेझेंटेशन मोड मध्ये हे करा सर.
हा ठीक
बाकी
आहे
ओके.
ठीक
हा
आहे.
थँक्यू सर. झालं ओके.
Okay. Good afternoon, everybody. The topic which is given for me is disaster management. So, in the first lecture, I will be covering some aspects of the disaster management, and I will discuss some points regarding the disaster management cycle. And in the second lecture, I will be covering the natural geological disasters, that is earthquake and landslide. So first we'll see the definition. I think you must have heard this definition also, but again I will just give these definitions for the hazard and disaster. Hazard is a potentially damaging physical event, phenomenon, or human activity that may cause the loss of life or injury, property damage, social and economic disruption, or environmental degradation. A primary hazard disrupts human settlements, and a secondary hazard occurs in the aftermath of primary hazard and contributes to further suffering or losses. Means if you have the primary hazard, because of primary hazard, there will be a secondary hazard also. It is not necessary, compulsory you will have the secondary hazard, but sometimes you will have secondary hazard. So I will explain when I will be doing the case studies. And what is disaster? Disaster is a serious disruption of the functioning of the community or a society, causing widespread human, material, economic, and environmental losses, which exceeds the ability of the affected community or society to cope up using its own resources. That means there is a slight difference between the hazard and disaster. Okay. So disaster management requires us to understand the difference between a hazard and a disaster. The difference is very, very minute, but it speaks volumes about human involvement in a natural phenomenon. So hazard is any phenomenon that has a potential to cause the destruction to the life and property. And a hazard become a disaster when the potential to cause destruction is fulfilled. When there is a harm to life and a damage to the property, then the hazard is termed as a disaster. And because of that, all disasters are hazards, but all hazards are not disasters. Because hazard has a potential to cause the destruction to the life and property. But if it is not fulfilled, that means hazard has occurred, but the damage is not there for the life and property, then it will remain as a hazard only. And when there is a damage or loss of life or a damage to the property, then we can call that hazard as a disaster. So in simple terms, a hazard is a dangerous situation or event that carries a threat to humans. A disaster is an event actually harms the humans and disrupts the operation of the society. So hazards will be considered disaster once they affect humans, but if they occur in an unpopulated area, they will remain as a hazard only. So for example, a earthquake hazard has occurred or earthquake was hit a barren mountain with no human community, it would simply be a natural phenomena or a natural hazard. So hazards can be geological, which is the most common one, biological, epidemics and pandemic, or chemical, nuclear power plant leaks, chemical industry leaks, and so on. So today, most hazards are turning into disasters simply because of the sheer extent of human communities in the world. We exist in almost every terrain. Though the terrain is difficult, still we go there and settle, and in every environment on earth. So consequently, even small scale hazard is nowadays turning into major disasters affecting a significant number of humans and their property. So what is the risk equation? The risk is the likelihood possibility that an area will be negatively affected by the hazard. So it is the risk that ultimately controls the possibility of converting a hazard into a disaster. And the word is often used to quantify the probability of a hazard turning into disaster. Risk equation. So this is the risk equation which is given by the scientist. Risk is equal to threat into vulnerability into cost. So threat is the frequency with which a hazard can hit the area. For example, the threat of an earthquake in Himalayas is extremely high as compared to other areas. Vulnerability, second component of risk equation. This is the weakness of an area towards that particular hazard. For example, the Himalayas is extremely vulnerable to earthquakes, but it is not vulnerable for the tsunami hazard. And the cost which is involved, this is the third component of risk. This is the human factor of hazard. More the number of humans and property, greater is the cost involved, and therefore greater is the risk. So risk is directly proportional to the threat, vulnerability, and cost. So when the risk is high enough, there is a greater chance of for a hazard turning into a disaster. So this is the classification of disasters. These disasters are classified into two, as the natural disasters and man-made disasters. Natural disasters are again classified into planetary disasters and extraplanetary disasters. Planetary disasters are again divided into terrestrial disasters and atmospheric disasters. Terrestrial disasters, they are classified into landslide, earthquake, volcanoes, and so on. And the atmospheric disasters, they are again subdivided into abnormal and cumulative. Abnormal means cyclone, thunderstorm and lightning, hailstorm, cloudburst. They are abnormal. Suddenly they will come. And the cumulative atmospheric natural disasters are flood, drought, cold waves, and heat waves. So here, flood will not happen in one day because water has to get accumulated. So this comes under the cumulative disaster. And under the man-made, again, these man-made disasters are divided into three: physical, chemical, and biological. Under physical, you have earthen, landslide, soil erosion. Now here, the landslide is included in the man-made disaster also and in the natural disasters also, because of the anthropogenic activities, human activity, you may have the landslide. Maybe when we are making the road, you will cut the hills. So, and because of that, the landslide is occurring. That's why it is included in the man-made also. And then under the chemical, you have nuclear explosion, release of toxic chemicals, ozone depletion, acid rain, oil spills. And under the man-made disaster, under the category of biological disasters, you have epidemic, eutrophication, population explosion, and influence of pests and insects. This is another type of classification of the disasters based on the speed: rapid onset disaster and slow onset disasters. The rapid onset disaster, again, they are subdivided into two: rapid onset natural disaster and rapid onset man-made disaster. Earthquake, cyclone, landslide, volcanoes, lightning, thunderstorm, forest fires. These are rapid onset natural disasters. And under the category of rapid onset man-made disaster, various explosions, fires, and accidents. And under the category of slow onset disasters, again, you have two categories, two divisions. Slow onset natural disasters, which includes the floods and droughts, and slow onset man-made disasters, population explosion, civil wars, epidemic, famine, desertification, eutrophication, oil spills. The various types of hazards and disasters, again, they are classified on the different aspects. Some are geological hazards. So geological hazards include earthquake, tsunamis, volcanic eruption, landslide, dam burst, mine fire. The disasters or hazards which are related to the water and climate, these are tropical cyclone, tornadoes and hurricanes, floods, drought, hailstorm, cloudburst, landslide, heat and cold wave, snow avalanches, sea erosion. Now here, geological hazards also include the landslide, as well as the water and climatic hazards also include the landslide. Because of the geological factors, if the landslide is occurred, then it is under this category, geological hazards. But because of the heavy rainfalls continuously, maybe for 10, 15 days, then you have the landslide, and then that landslide comes under the water and climatic hazards. And you have environmental hazards also, like environmental pollution, deforestation, desertification, pest infection. And there are some biological hazards like human and animal epidemics, pest attacks, food poisoning, and weapons of mass destruction. So why is disaster management important to us? Because some disasters are predictable in advance. Some are annual and seasonal. Some are sudden and unpredictable. So floods, these are predictable in advance. Before a few days and few weeks, you can predict the flood hazard because you will see rise in the water level in the rivers. And based upon that, and whatever the meteorological prediction about the rainfall in coming days, if you model that, you can come to a conclusion whether in recent 2-3 days you will have the, or within few days you will have the floods or not. Earthquakes, just few seconds or few minutes you can predict in advance, but earthquake prediction is very, very, very difficult. You cannot predict it. Cyclones, yes, few days before you can predict. So droughts, few months, because you know what are the water resources, how much is the water which is available on the surface water bodies, how much water is available in the aquifers or under the ground, that is the groundwater, and what is your requirement. Based upon that and based upon the prediction of the rainfall, you can predict whether this year you are going to face the drought situation or not. So floods, cyclones, and droughts, these you can predict in advance. These are annual and seasonal disasters. An earthquake is a sudden and unpredictable. This is the disaster vulnerability map of India. Here, different categories are given from lowest, low, medium, high, and highest. Different color codes are given. Here you can see the Himalayan region. Here you have highest disaster vulnerability because this is very, very tectonically very active region of India. If you see the Maharashtra, in the Maharashtra, low and lowest disaster vulnerability is there. Here you can see the major disasters in India. State-wise, the disasters have been shown. Here you can see in the northern region, you have the earthquakes. In the Himalayan region, you have the avalanches or glaciers. Then you can have the flood disasters in the northeastern portion. And then you have earthquake disasters in the Gujarat also, in the Maharashtra also, Kilari and Koina area, they are prone to the earthquake. In the Maharashtra, you have the flood disasters also, you have drought disasters also. On the Western Ghats, you have the landslide disasters also. In the coastal, western and eastern coastal areas, you have the tsunami disasters. The tsunamis are more prone in the eastern coast of India. Then you have the cyclone disasters. These cyclone disasters also mostly they are concentrated in the eastern coast of India, and sometimes you may have some cyclone disasters on which are hitting the western coast of India also. This is the seismic zonation map of India. Here the zones have been shown in this map. About 59% of the land area of India is liable or is prone to the seismic hazard disaster. Zone 5, it is very high risk zone. Area is liable to shaking intensity up to 9. Here you can see this red color here in the Himalayan region, in the northeastern region, and here. Zone 4 is high risk zone. Intensity may go up to 8. Here is one patch in Maharashtra. Here is the Koina in the western part in Satara district. So this is the zone 4. Then zone 3, yellow color. This is moderate risk zone. This yellow color you can see, moderate risk zone. Kilari comes in this 3 and 2. And zone 2 is a low risk zone. So remaining part of India comes under the zone 2. This is the landslide zonation map of India. Here you can see northern India and northeastern India is highly prone to the landslide hazards, and some locations in the Western Ghat and on the eastern coast or eastern India, you may have some locations where you may have the landslide hazards. This is the landslide map again. Here you can see the highly affected areas. They are concentrated in the Kashmir, Jammu Kashmir areas, then northeastern areas, and moderately affected area. Our Maharashtra state comes under this moderately affected area. Maharashtra, Karnataka, Tamil Nadu, and Kerala. These are the states where you have the moderate landslide occurrences, and remaining area where you have marginally affected, and some areas there we don't find any landslides. And on the right hand side we have the India map showing the cyclone prone areas. Here you can see the eastern coast is highly vulnerable for the cyclonic disasters, whereas some parts of the western coast, they are prone to the cyclone disaster. Then landslides also. Then you have the volcanoes also. So if you see the statistics, that is very, very alarming. Almost 57% of the land area is prone to the earthquakes. 12% of the land area of India is prone to the floods. 8% area is prone to the cyclones. 70% of the cultivable land is prone to the drought disasters. 85% of the land area is vulnerable to number of natural hazards, almost 85%. Some of the hazard will occur there. and 22 states are prone to multi-hazards, like Maharashtra. In Maharashtra, we have the earthquakes, we have the landslide, we have the flood, we have the drought. So many disasters, and man-made disasters are also there. So 22 states of India are prone to multi-hazards. So what is the disaster management cycle? Disaster management is a cyclic process. The end of one phase is the beginning of another. Although one phase of the cycle does not necessarily have to be completed in order to the next to take place. Often several phases are taking place concurrently. So if you see this disaster management cycle, on the right hand side, you have the components of disaster management cycle which are after the event, and on the left hand side you have the components which are before the event, before the disaster. So here on the right hand side you have the response and recovery, that is the after the event, and on the left hand side you have preparedness and prevention, that is before the event. So under the response category, again you have the emergency management, then infrastructure and services restoration, and under the recovery some part comes of the reconstruction also. And on the left hand side you have the components which are before the event, the prevention and preparedness. So prevention includes the risk assessment and planning, what type of planning you are doing. That planning will be based on the what is the risk, how much is the risk. So if you calculate, if you put the components, if you put the values in the risk equation, then you can calculate the risk assessment, risk, how much is the risk, and based upon that you can do the planning and reconstruction. And under the preparedness, you have the pre-disaster activities. There are a number of activities you can conduct before the disasters. Of course, wherever the disasters are occurring almost quite frequently, in those areas, you can give the training, you can have the workshops, and you can make the people aware, and then these people, they will get prepared to face the disaster. So how you are going to give the response, and what rescue operations you are carrying out after the disaster. So response has to be very quick. Then what is the rehabilitation? Because the people will lose their houses, then you will have to rehabilitate the people in areas where you don't have the threat of the disasters. And reconstruction or development, maybe you can build the houses, or you can do the construction in the same area, or you can choose another area which is not very prone to the disaster, and there you can go for the development and reconstruction. And prevention, mitigation, and preparedness. So these components we will see one by one. So mitigation, preparedness, response, and recovery. Then first is mitigation. Measures the put in place to minimize the results from a disaster. Steps taken to reduce or eliminate the disaster impact. So what are the steps you have taken for the mitigation of the disaster? It may be a landslide, it may be an earthquake. So what are the different steps you have taken? When I am dealing with the earthquake and landslide disasters, that time I will speak about what are the different steps you can take before the disaster to minimize the effect, or to minimize the loss of life, and to minimize the loss of property in the disaster. For example, what are the building codes, and what is the zoning, what is the vulnerability analysis, and what is the public education. The second component is preparedness. So planning how to respond, because the people, they will become very panicked if the area which is not experienced in previous days any disaster, and suddenly any disaster is occurring. Maybe in new area we have the earthquake disasters. So immediately the people, they will get panic because they don't know, they are not experienced. So how to respond? So they will not be able to respond very effectively. So, for example, preparedness plans, you should have the preparedness plans, you should have the emergency exercises, you should have the training and warning systems also. So, plans, procedures, training, and education coordination. These are the things which are very important in the preparedness activities. Then response. Initial actions taken as the event takes place. For example, evacuation. You have to evacuate the houses. Then search and rescue operation and emergency relief. What are the things which are immediately required? What is the emergency needs? So you should know what are the things which are required immediately in the relief or in the rescue operations. And if you have complete kit of that, then you can save the lives and you can save the property. So how quick you can respond to the situation, that is very, very important. And recovery, returning the community to a normal situation. Ideally, the affected area should be put in a condition equal to or better than it was before the disaster took place. For example, temporary housing you can provide. You can provide the grants, you can provide the medical care also, but the conditions should be equal or should be better than the earlier. Then restoration to the pre-disaster condition. So what was the condition before the disaster? So you will have to restore the situation to the pre-disaster condition. So that is very, very important. So what are the requirements? The application of management functions to disaster situation so as to effectively use the available resources to prevent, reduce losses of property and the life, environment, and to normalize the situation. So you have to use effectively the whatever the available resources are available. Suppose water resources are very limited. So you have to use those resources very carefully till you get additional water resources from other sources, or maybe medicines, or maybe some things which are very, very essential. So you have to see and effectively you have to use these resources, or maybe food grains are there. So effectively you have to use. You cannot consume in a 1 day or 2 day because you do not know when you will restore the situation. So it includes the planning, organizing, staffing, directing, coordinating, reporting, and budgeting functions before the disaster attacks, and rescue, relief, and rehabilitation work after the disaster attacks. So before disaster, you should have the plan. Suppose a particular area is going to have the earthquake disaster, or maybe landslide disaster, or maybe flood disaster. So what are the plans we have? Then what is the staff requirement for the rescue? Whether that much staff is available or not. Then directing. So somebody will give the directions. So those directions should be proper. Then coordination is very, very important. You have to coordinate with many things. You have to coordinate with the people, you have to coordinate with the government officials, you have to coordinate with the government offices, you have to coordinate with the NGOs, you have to coordinate with the police people, you have to coordinate with the civil people, you have to coordinate with so many departments and so many people, and reporting, and you have to report also, because false reporting will again create the panic in the people, because some people they elaborate the things, and they will expand the things, and they will tell, even if the loss is less, they will report very big figures. But again, that gives the panic, that creates the panic in the people. So reporting to the media, reporting the doctors, reporting to the government officials, that is very important, and correct reporting has to be there. Then budgeting, how much budget is available, that also you'll have to see. Now every collector office has the disaster management cell, so you can see how much budget is there, what are the things which are available there, because these are the things which you should know before the disaster attacks. And rescue, relief and rehabilitation work after the disaster attacks. So how you are going to rescue the people, how you are going to give the relief to the people, and how you are going to rehabilitate the people. So their planning is also very essential. Suppose an area is hit by earthquake, so where you are going to rehabilitate the people, so in advance only you will have to fix the areas. Suppose in this area, you know that area is vulnerable for which type of disaster, and suppose that disaster hits that area, then you have to rehabilitate the people. So for that, identification of the land is also very important. It also needs proper leadership, information technology, research and development, and time management, responsibility management, risk management, performance management, strategic management, financial management, communication management, and knowledge management too. So there are many managements are included in this. So you should have the proper leadership. The leader who is giving the directions should be proper. He should know what directions are to be given. These directions should be proper. Otherwise, again, you will have the loss of life or loss of property also, if the directions are not proper. Then information technology, you have to communicate with the people. So the information technology has to be there, maybe internet, maybe mobiles and other things. Then research and development, so what is the research which is carried out in that particular area? Suppose in the earthquake prone areas, so a lot of earthquake recording equipments are kept to record the earthquake intensity or magnitude. So how the area is fully equipped with the research and development activities. Then time management, because some things are provided or needs to be provided within short period of time. Medicines, you have to give immediate. Those persons who are highly injured, you have to give it immediate medicines. So you should not waste the time. Or for the rehabilitation, you should not waste the time. So time management is also very important in the rescue operations. Then responsibility management. So if many persons are there, they have to share their responsibility. Okay, 2-3 people will carry out this type of activity, 2-3 people will carry this type of activity, 2-3 people will carry out this type of activity. So that is very essential, and that you can do it in the training part. The risk assessment, risk management, performance management. The persons who are involved in the rescue operation, their performance has to be proper. Otherwise, they have come for the rescue operation and they just doing time pass, and they are just sitting idle, or they are doing some small works. That is not enough in the after disaster activities. So performance has to be proper. The strategic management, strategically you have to take the decisions. the people who are there if disaster occurs, because at that time only the residents of that area are there. So what to do? That needs to be fixed. What is the first step? What is the second step? So that comes under the strategic management, so that you can minimize the loss of life and loss of property. Then financial management also. Then communication management. As I told you, communication has to be very, very proper. You have to communicate the right things to the right people. If you communicate wrong things to the right people, again you will have the problem. And you can communicate the right thing to the wrong people, again you will face the problem. So that's why the right communication to the right people, to the right agency, to the right officials is very, very important. And you should have the knowledge management also. So these are the different many managements which are involved in the disaster management. So if you see the characteristic of natural disasters, predictability, you have low predictability and high predictability. As I told you, low predictability in the case of earthquake, you cannot predict, maybe few seconds or 1 or 2 minutes, and that is not sufficient. And you have high predictability like for droughts and for floods. Then initial lethality. In some disasters you have high lethality, in some disasters you have low lethality. Then scope is low and high also. Then onset delay, slow and sudden also. So earthquakes, they are sudden, cyclone, they are sudden, and floods and famine, they are slow. So these are the different characteristics of the natural disasters. So it is virtually impossible to prevent the most disasters. Nevertheless, we can prevent or you can lessen many of their worst effect or bad effect by anticipating them and by being prepared. Suppose your area is prone to some type of disaster, maybe flood, maybe drought, maybe earthquake, then you are anticipating that, okay, my area is vulnerable for this type of disaster, and then you will be prepared. You will not be prepared, and when you are not prepared for facing the disaster, then loss will be more. If you are prepared by anticipating the disaster of your area, you can minimize the worst effect. The greatest number of disasters occur in those countries that are already most adversely affected by ill health and poor economic conditions. Then disaster trauma, suffering. So there are 3 categories of disaster suffering or trauma: physical disasters, psychological disasters, and socio-economic disaster. Under the physical suffering, you have the fractures, burns, injuries, infections, poisoning. Under the psychological, you have depression, grief, anger, guilt, apathy, fears, the burnout syndrome, bizarre behavior, suicide, behavioral anxiety, alcohol abuse, stress reactions. And the socio-economic, you have environmental destruction, unemployment, disorganization, and homelessness. Now, you have recently faced the corona disaster, that is pandemic. So many people, they went under the depression. Many people, they have faced stress conditions. Many persons, because of the fears they have died. Almost they have recovered, but the other person died, which is close or next to his bed, he also died. Then unemployment. The corona disaster has faced this problem also, unemployment problem. So many sufferings are associated with disasters. So what are the approaches? Rescue, relief, rehabilitation, and follow-up. The psychological response to disaster will depend on three main factors. That is the disaster, what is the magnitude of disaster, and what is the response. So what type of disaster is there? What is the magnitude of that particular disaster? Then what is the response? The response which is given by the victim and response of the community. The disaster, the occurrence, where it has occurred, what is the magnitude, what is the suddenness of that disaster, and what is the type of disaster. The community, the level of preparedness, social support. So whether the community is well prepared to face the consequences of disaster, yes or no. In the community, whether you have the leadership, and that is, you should have the proper leadership, and whether that community has past experience. Because you have the past experience, then in the next time you will perform in a better way. And if you don't have the past experience of a particular disaster, then you do not know what needs to be done if you are not very well trained. If you are trained, you can manage the situation without past experience also. And the victims. So what is the age of the victim? What is the level of education and exposure of that victim? What is the marital status? And what is the physical health of that victim? Generally, if the disaster occurs, then generally the small children and old people, they get more suffering because of the disaster attack. If the physical health is not proper, then also the people, they will suffer more. So these are the things which are very essential. So speed and direction, these are the key issues. What is the speed and what is the direction? The key issues are quick assessment. You have to assess very quickly which disaster has hit, how much is the loss of property, how much is the loss of life, how much area is affected. That is in general, you have to do the quick assessment, and accordingly, you have to give the immediate response to that. Then quick planning. Planning has to be very quick, and then quick planning will lead to the coordination, proper coordination, correct coordination, right coordination with the right people. And quick execution or action, it will result into the desired results. So that quick execution and quick action, quick assessment, quick planning, immediate response, right coordination with the right people, it will minimize the impact of the disaster, and you can save some of the lives, you can save some of the properties, and you can overcome the disaster. So what are the guidelines? Crucial rehabilitation process. The first objective is to get water, food, electricity, and sewage system restored. Plan temporarily housing within few weeks. so that the people can move out of the temporary housing, because immediately if some disaster occurs, immediately we put the people into the schools. Then long-term housing is essential to use the locally available material. You can use the locally available material and you can go for the long-term housing. Then getting people to build their own houses has a twofold purpose. It provides the people with an income, it gets them involved and interested in the design and construction of their house. And this participatory approach gets them out of the depression and lethargy that follows the trauma. Because many people, they will be under depression, they will be under lethargy when they face the disaster. So you have to get involved people in these works also, so that they are involved in this type of works, different types of works, so that they will forget the impact of the disaster and they can overcome. There is a need for institutionalization of process for learning from experiences obtained from disasters. So creation of information and data clearing house on disaster management. You have to create the data bank also. Creating knowledge centers in each locality. So wherever the disasters are occurring very frequently, in those areas, you should have the knowledge centers. So in the knowledge centers, you can keep the disaster record, total history of the disaster, that particular disaster, and how to overcome that disaster, what are the preparedness plans, what are the rescue operations. So all the details you can keep into the knowledge centers. Then readiness and develop strategies and interventions. Act on lessons learned from evidences based on research and practical experience. Fire in building, life, lift, staircase. Suppose, what is the practical experience? Suppose the building has caught the fire and somebody has used the lift. So you should not use the lift if the building caught the fire, because maybe the electric circuit will get burned and maybe the lift may stuck in between and you cannot come out. So you'll have to use the staircases if the fire is caught by the building. So you can learn such things from the practical experiences, earlier experiences. Okay, so the safety ships, tanks should be there, like for Bhopal gas treasury, one example is there. So these are the things which are very, very important. So what are the components of disaster preparedness? So on the left hand side, the phases are given, and on the right hand side, activity which needs to be carried out before the disaster. The hazard phase is hazard. So what is the activity? Identification of hazards. So in your area, what type of disasters will occur? Maybe one disaster, two disasters, three disasters, or multi-disasters. Then identification of vulnerability, how vulnerable your area is. Then assessment of the risk. Maybe suppose you are staying in a big city. Maybe one part of city is vulnerable to one type of disaster. So that demarcation has to be done before the disaster. Then prevention, removal of the hazard. If it is possible, you can try to remove the hazard. But many times it is not possible. That is not in our hand in case of the natural disasters or natural hazards. Of course, in man-made hazards, you can do this. Then selection of alternatives. So what you can do, what is the alternative which is available with you? Then hazard control, how you are going to control the hazard. So these are the steps we can take in the prevention phase. Then planning and mitigation, contingency planning. So you require the financial aid, the knowledge of rehabilitation methods, how to rehabilitate the people what are the different methods. Now these methods are different for different disasters. Of course, there are some methods which are very common. Then instituting organizational framework. So how you are doing planning? Maybe one person is there who is the leader. Below him, how many people are there? Maybe 5 people, maybe 10 people. And below them, again, you have, so you can have the tree network of the people who are involved or who will be involved in the mitigation, planning and mitigation. And that depends upon what type of disaster, what is the magnitude of the disaster, how much area will be suffered because of that particular disaster. It depends upon that, how many people you required for the planning and mitigation and in the rescue operation. Then these are the activities after the disaster. Emergency, accurate response and speed of action is very, very important. Response has to be accurate and speed has to be there in the actions. And then you can go for the follow-up. In the follow-up phase, knowledge of disasters, fencing the impact area. You have to cover the area. Otherwise, many thefts will occur. In Kilari area, when the earthquake took place, so many people, they came there and they have taken the gold and money from that Kilari area. So you have to protect the area. Fencing of the impact area is very important. Diagnosis of needs. What are the things which are required? That diagnosis has to be there. Then implementation, then monitoring, feedback and adjustment, and information transfer and storage. You have to transfer the information as well as you have to store the information for the experience purpose. So before the disaster, you can do the assessment of the hazards. Type, what is the type of the hazard? What is the scale of consequences? Means how much impact it will have. Then what are the available resources? That depends upon but what are the resources which are required and how many resources which are available. Then allocation of duties to the specific personnel. So you have to identify the people so that you should know the people. Okay, this person is good for this person is good for this person is good for this activity. And accordingly, you have to allocate the duties to the specific personnels. You have to give the training to these specific personnels so that they can do a very good work if the disaster occurs. And liaising with the external organizations. Maybe you have the government officials, you have NGOs, or maybe within your district, within your state, other than your state, other than your country. So that liaising with external organizations has to be given. So these are the things which are very, very important, because if you don't have the liaising with the external organizations, then it cannot, it is very difficult to manage, or it is very difficult to cope up with the disaster. So if we have the good liaising with the external organizations, immediately you will get the help from the organizations. Because sometimes if the impact is more, then whatever the resources which are available, whatever the manpower which is available in that area is not sufficient. So you'll have to take help from the external organizations. During the disaster, site action, alarm warning, evacuation of the area. You have to evacuate the area. Otherwise, what happens? The rescue operation will not be proper. because suppose there is no road to go inside, there is no road to take the equipments inside. Suppose the collapsing of houses is there, so immediately you have to evacuate the some part of the area, so that whatever the machinery which is there, it can reach to that affected area. Accounting for personnel, local emergency actions, emergency service assistance, provision of information, then advice, direct assistance, collection of information and communication, and medical first aid. So these are the things which are required during the disaster. And what are the components of which are involved in the after disaster? Preservation of evidence. You'll have to preserve the evidence. Suppose earthquake has occurred, flood has occurred, drought has occurred, then you should have the evidences. Based upon the evidences only, you will get the financial aid from the government office. If you don't have the evidence, then you cannot get. Then site safety and security, as I told you, the impact area has to be safe. Otherwise, the people, they will come and they will take everything away. So safety and security is also very important. Then temporary services and operations. Sometimes maybe electricity is not there, water pipelines, they are broken. So you have to provide the temporary services and operations to that impact area. And site clearance, as I told you, after the disaster, you'll have to clear the complete site. So these are the things which are important. And this is the table which is showing applications of space remote sensing in disaster management. So here in the first column, the disasters are given, prevention is given in the second column, in the third, preparedness or warning, and in the fourth column, relief is there. So earthquake, volcanic eruptions, landslides, flash floods, major floods, storm surges, hurricanes, tornadoes, and droughts. Here you can use the geological maps, lineament maps, land use land core maps, topographic maps. Then you can use the satellite imageries for this, and based upon that, you can have the plan of action. And then you can go for the preparedness based upon the hazard zonation analysis or hazard zonation map. For example, in the landslide area, what is the rainfall? What is the slope stability? If you study these two parameters, then what is the slope angle? So if you study these parameters, you can make the hazard zonation map. Okay, this particular area is having low landslide potential, low prone area, medium prone, high prone. You can make three categories: low prone area, medium prone, and high prone area for particular disaster. For different disasters, you can have different maps. For earthquake, you can have a separate map. For volcanic, you can have separate map. For landslide, for floods, for droughts, for cyclones, you can have the separate hazard zonation maps. And based upon that, you can have the preparedness plan for that particular area. Thank you very much. Hello? Hello, any questions are there? If you have any questions, please let me know. Your mic is off.
It is on, sir.
Yes?
Mic is on.
You have any questions? Please ask me. because first lecture I have finished.
Our mic is on.
Yes, yes. Can you hear me? ऐकू येते का माझं बोलणं?
Yes, sir. Yes, sir.
If you have any questions, please ask me. I have finished with first lecture.
अपना माइक ऑफ करा है सबने, ऑन करा है. You can ask on a mic also.
अब मेरा ऑन ही है. आपको कुछ क्वेश्चंस है क्या? क्वेश्चंस है तो पूछो. Otherwise, we'll take a break of 5 days, 5 minutes. We'll take a break of 5 minutes and then we can start with the next lecture.
Sir, one question is there from participant.
Okay.
For hazard donation mapping, which GIS analysis method is useful?
GIS is a software where you can
Which software? hazard mapping के लिए कौन सा GIS सॉफ्टवेयर यूजफुल रहेगा?
ArcInfo is there. LVC is there. These softwares you can use it for the mapping. You can prepare the map. You can create the different thematic layers by using the satellite data and GIS software. ArcInfo is the best software. So shall we take a break of 5 minutes?
Yes, sir.
Okay, okay. Again, I will join. Shall I log out?
Yes, sir. Yes, sir.
Okay, okay, okay.
Who has prepared for vote of thanks? Roll number?
Roll number 28, madam.
Okay, you are ready now, ma'am? 6 o'clock, huh? Okay. Shall I talk now? If everybody listening to me? Hello? Hello? Tomorrow, there is a summary and report writing of roll number 29, 30, 31 and 32. Means they are going to read summary and report of today's session on a tomorrow morning. And for tomorrow, biodata reading is there. 33 number is there. For 34, vote of thanks. For 35, there is a again afternoon biodata. And for 36, there is a vote of thanks. Am I audible to all of you? Your mouse is muted. Report writing, you can have that biodata also with you. Table is there. Through that table, you can study that. Who has a report writing and summary writing. And again, one issue is there. One roll number 35 is not present for tomorrow. Anybody going to read tomorrow afternoon biodata for him? Anybody willing to read biodata of afternoon session for 35 number? Then whenever you have a duty or whenever you have that task, he is going to do your task. If anybody ready, then you can send me the message on a WhatsApp for roll number 35. Afternoon session biodata is there. If you have that summary and report writing data, you should send it on a mail because on a WhatsApp, sometimes I am unable to see it. Please send it on a mail only.
Problem 27. $28.
Yes, sir. Yes, sir.
सर का लेक्चर खत्म हो चुका है क्या? सर ने ब्रेक दिया है क्या सर? Problem 67.
ब्रेक आहे सर, ब्रेक. पण बराच वेळ झाला सर ब्रेकला. Near about 10 minutes is there. Sir, sir is joining now. Hello, Gaurav sir. Gaurav sir.
Roll number 28.
Sir, roll number 67 is there. Sir has
हम्म,
taken a break from 10 minutes.
ठीक है वेट कीजिए सर ज्वाइन करेंगे.
Okay, okay, no problem.
ठीक है मैडम.
हेलो हेलो
हाँ, hello.
Hello,
sir.
sir.
Welcome.
My mic was unmute.
Yes, sir. Audible.
Okay,
Audible.
okay. Screen is visible?
Yes, sir.
Yes, sir. Yes.
Okay. So, in the first lecture, we have seen the different types of disaster, classification of disaster, what are the things needs to be done before, during, and after the disaster, and we have seen the disaster management cycle also. So, in this lecture, we will see the specific two geological hazards, earthquakes and landslides. So, what are the earthquakes? An earthquake is a sudden temporary motion or a series of motions which originate in a limited region and then spread out from the place of origin in all directions. The shaking or trembling, which is caused by the sudden release of the energy, and that energy is released below the earth surface, and this is usually associated with faulting or breaking of the rocks below the ground. So, continuous adjustment of position results in the aftershocks. So, once you have the earthquake, then again adjustment of the earth surface will take place, and because of that, you may have some minor aftershocks also. So, earthquake occurs in 50 to 100 kilometers of depth below the surface of the earth. So this is the map which is showing where the earthquakes generally occur. So all these red spots, they are the zones of the earthquake. Here is the India. Here you can see this is the Himalayan region, which is very prone to the earthquakes, and some locations are here. And this is the circum-Pacific belt, which is highly prone to the earthquakes. These are the boundaries of the plates, continental plates. So 80% of all earthquakes occur in the circum-Pacific belt. Most of these result from convergent margin. Nearly 15% occur in the Mediterranean Asiatic belt, and remaining 5% occur in the interiors of plates and on spreading ridge centers. So, like Kilari and Koinanagar earthquake in Maharashtra, they occur within the plates. They are not occurring at the borders of the plate. More than 1,50,000 quakes strong enough to be felt are recorded each year throughout the globe. So this is a diagram where two terminologies are used in case of earthquake disaster: focus and epicenter. So focus is a place of origin of earthquake inside the earth. Here is the focus. So this is the surface of the earth, and below the surface of the earth, the focus will be there. And generally, every time the focus depth changes, it ranges from 1 kilometer to maximum up to 10 kilometer. And epicenter is the point on the earth's surface exactly above the focus. Exactly above the focus is the epicenter. So epicenter is on the surface of the earth, whereas focus is below the surface of the earth, where the energy is released. So this is the equipment seismograph. This is the old equipment which was used to record the vibrations of the earth, especially earthquakes. So this is the drum, and here you have the needle. So this is the very old one nowadays we have the digital seismographs. So digitally the data is recorded. And the seismogram is a real-time record of the earthquake ground motion recorded by seismograph. So seismograph is a equipment and seismogram is a record of the earthquake. Okay. And that record is used for the calculation of location and the magnitude of the earthquake. So this is the scale which is given by the scientist Richter. That's why it is known as Richter scale of earthquake. Generally, we know we have experienced 4 magnitude earthquake, 5 magnitude earthquake. So here, that is the magnitude which is given here. That is given by the Richter. That's why it is known as Richter scale of earthquake. And here is the description given and what is the effect. If the magnitude is ranging from 0 to 2, it is a micro earthquake and it is never felt by the people. It is felt by the equipment, it is recorded by the equipment, but it is not felt by the human beings. Maybe if you are very close to epicenter, then you can feel it. The magnitude ranging from 2 to 2.9, it is termed as minor earthquake. It is experienced but not recorded in the seismograph, which are away, very, very away from the epicenter. If it is close to epicenter, it will record. The magnitude ranging from 3 to 3.9, it is again minor earthquake experienced, but no damage is caused. So people will feel that earthquake, but the damage will not be there. Magnitude ranging from 4 to 4.9, it is a light earthquake. Shaking and rattling of items is experienced, but no significant damage is caused. Of course, if the building is highly damaged, then some damage will cause to that building. Otherwise, significant damage will not there. Maybe some minor crack will be there in the areas which are close to the epicenter. The magnitude ranging from 5 to 5.9, moderate earthquake. It affects weak construction and causes mild damage to stronger constructions. Magnitude 6 to 6.9, it is a strong earthquake, affects areas up to 160 kilometers from the epicenter in the populated areas. So at Koinanagar, in the year 1967, 6.3 magnitude earthquake had occurred, and even in the Kilari, in the year 1993, 6.2 or 6.3 magnitude earthquake has occurred. 7 to 7.9, it is a major earthquake. It can spread to further areas and cause severe damage. 8 to 8.9, great earthquake, can go beyond 100 miles and cause the severe damage. 9 to 9.9, great, can go beyond the 1,000 miles with disastrous effects. And 10 plus is epic, never been recorded. Till today, the 10 magnitude earthquake is not yet recorded, not yet occurred. So this is again the description. 1 magnitude 1 to 4, these are small earthquake, and in the earthquake prone areas daily you will find these earthquakes. Then 5 to 6 magnitude earthquake, they are moderate earthquake and monthly they can occur. 7 magnitude, these are major earthquake, monthly or maybe every 50 years. 8 and 9, they are great earthquake. Sometimes they occur in maybe 100 years or 300 years. And 10 magnitude earthquake is never recorded till today. This is the earthquake magnitude and the comparison of frequency, magnitude, and energy that is released because of the earthquake. How much energy is released by earthquake. So we'll see another table which is slightly simple. If the Richter scale is ranging from 0 to 1.6 to 20 kilogram of dynamite explosion, how much it releases the energy, that much energy is released by the 1 magnitude earthquake. So it is commonly known as TNT, and is an explosive which is used in military shells, bombs, and grenades, in industrial uses, and in underwater blasting. It is 2,4,6 trinitrotoluene production in the United States occurs solely at military arsenals, or trinitrotoluene. It is an explosive solid. So this is the table which is showing how much energy is released. If you see the 6 magnitude earthquake, it is releasing energy that of you are exploding 60 million, 60 lakh kilogram of dynamite. That much amount of energy is released in this earthquake. So it is very, very big amount of energy which is released by the earthquakes. And this is the logarithmic scale. Magnitude 3 earthquake is 1 time more than the 4 magnitude, but 5 magnitude earthquake is 10 times more than the 3 magnitude earthquake. Likewise, it will go on changing 10 times, 100 times, 1,000 times. So it is not the simple normal scale. The energy released in earthquake changes even more rapidly with each increase in the Richter scale, because the number of high amplitude waves increase with bigger earthquakes, and also because of the energy released is according to the square of the amplitude. Thus, it turns out at the end, an increase of 1 on the Richter scale corresponds to the 30-fold increase in the energy which is released. The largest earthquake recorded is 9.5 Chilean earthquake in the year 1960, each of which released the energy equivalent to approximately 10,000 nuclear bombs, the size of the one which was dropped at Hiroshima. So that much amount of energy was released in the 9.5 Chilean earthquake. This is another scale. It is called as scale, or modified Mercalli scale. So on the left hand side, you have the modified Mercalli scale. It is ranging from 1 to 12. It is denoted by Roman numbers 1 to 12. And on the right hand side, you have the Richter scale, which is ranging from 1 to 10. And these are the effects. Like, for example, earthquake 2 scale. It is felt by only few people, especially on upper floors of the tall buildings. Ground floor people, they will not feel that particular earthquake. So exactly 3 intensity scale does not match with 3 Richter scale magnitude. Okay, this scale is different, this scale is different. This scale is based on the how much devastation, how much damage has taken place. Based upon that, you have the scale, which is ranging from 1 to 12. Whereas the magnitude scale, Richter scale, it depends upon how much energy is released by that particular earthquake. Same thing. This is again the same map, seismic zonation map of India. I have already shown you in the first lecture. Here you can see this is the Maharashtra state. Here is the Koyna Nagar. Here you have the 4 zone 4, and this is the Latur, where it comes under zone 3. So what are the causes of earthquakes? Types and behavior of seismic waves we will see before that. You have body waves and surface waves. Hello. ओके ठीक है ओके अच्छा ठीक है बोल देता हूँ मैं ओके सो you have two body waves. One is primary or compressional, and second is secondary or shear waves. And another waves are the surface waves. You have Rayleigh wave and Love wave. Here you can see the diagram. These are the primary waves. The particle motion will be in this direction. Here you have secondary waves. Particle motion is like this. Here you have low wave. The particle motion will be on the right and left hand side to side motion will be there. And this is the Rayleigh wave, up and down. Direction of the Rayleigh wave is the up and down. The primary waves, these are the fastest waves. They travel through the solids, liquids, and gases also. The compressional wave material movement is in the same direction as the wave movement. This is the wave movement, so direction of the wave movement material will be in this direction only. The secondary waves, it is slower than the P waves, and it will travel through only solid. These are the secondary waves. These are the primary waves. These primary waves can travel through the solid, liquid, and gaseous medium, whereas the secondary waves, they travel in the solids only. The shear waves move material perpendicular to the wave movement. So suppose this is wave movement is from left to right, it is perpendicular to the wave movement, up and down like that. Then you have Rayleigh wave and low wave. These are the surface waves. They travel just below or along the ground surface. Slower than the body waves. The rolling and side to side movement will be there. Rayleigh wave movement will be like this, rolling, and low wave movement will be side to side. These surface waves, they are especially called as damaging waves. They will damage the buildings, these surface waves. Same thing is here. Here you can see this is the compound, and this is actual figure. This is the diagrammatic view. Here you can see, and here you can see this is the fault line. Along this fault line, this surface has moved in the right direction, and this surface has moved in the left direction. So here you can see this is the compound of that particular building. Almost offset is of 3 meters. So 3 meter shift is there in the because of the earthquake. This is the photo from the San Francisco earthquake, which occurred in the year 1906. Almost 3 meter shift was there. So you can consider along this fault line, whatever the building, whatever the structures were there, they are completely damaged. The seismic behavior of the waves, P waves, they arrive first when the earthquake occurs. First wave, those are arriving to the equipment are the P waves, and then S waves, and then L and R waves. So here you can see average speeds for all these waves is known. So after an earthquake, the difference in arrival times at a seismograph station can be used to calculate the distance from the seismograph to the epicenter. So here you can see this is the seismogram. Okay, the equipment is seismograph and the record is seismogram. So this is the arrival of P waves. This is the fastest wave. It will reach the equipment first. Then there is the arrival of S waves. So how much is the time lag between these two waves? That is taken for the calculation of the epicenter location. What are the causes of earthquakes? Because of the volcano. Now here, as I told you in first lecture, I told you that primary hazard and secondary hazard. Now here, if the volcanic activity is occurring, volcano is erupted, so volcano is the primary disaster or primary hazard. And because of the volcano, you have the earthquake. Then that is a earthquake is a secondary disaster. Okay, because of the, suppose you have only earthquake, so earthquake is a primary disaster, and because of the earthquake, maybe landslide has occurred, or maybe in buildings fire has taken place. So these are landslide and fire, these are secondary disasters. So you have primary disaster, and sometimes, not always, sometimes because of the primary disaster, you have secondary disaster. Like tsunamis. Tsunamis is a secondary disaster. It is because of the earthquake. Then isostatic adjustments are there because you have the mountains and you have the valleys. So the continents, they will try to adjust. That adjustment is called as isostatic adjustment. Because of that, the earth will shake, and because of that, you will have the earthquakes. Then you have the faults. Faults means the line. In the previous picture, I have showed you the fault. The fault is a line along which the displacement will take place. Horizontal displacement or vertical displacement of the two portions of the Earth's surface. Then elastic rebound theory, like rock elasticity, that also causes the earthquakes. Then accumulation of water, like in Koyna Dam, the people are saying that because of the accumulation of water, the pressure is exerted on the below rocks, and because of that, the along the faults, the movement is taking place and the earthquakes are occurring. And then you have the local causes like landslides, emission of water vapor under high pressure, and sudden collapse of roof in the karst region. Karst region means the limestone area. The limestone is a rock which is composed of, or the chemical composition of limestone is calcium carbonate. So the calcium carbonate will get dissolved, and you will have the sinkholes in the limestone area. And because of that, sudden collapse will be there. Because of that, you can have the earthquakes. So how earthquakes impact the environment? The collapsing of building will be there, property damage will be there, mud slide will be there, landslide will be there, fires will be there, flood will occur. Suppose because of the earthquake the dam has burst, then you will have the flood situation. Tsunamis are also there, loss of power will be there. So what are the impacts of earthquakes? So these are the negative impacts. Large scale destruction of life and property will be there. Rivers are obstruct, they are causes floods. Suppose in the rivers the landslide has occurred, so it will obstruct the water, and again you will have the floods in some areas. In Assam, it has occurred in the year 1950. Then if earthquake occurs in the sea, then you may have the tsunamis. We have experienced, the Indian continent has experienced the tsunamis in the year 2004 in the eastern coast and slightly on the western coast also. Then it is responsible for big faults, thrust and folds, which obstruct the transport and communication. These are the examples: Japan in 1891, California in 1906. Then landslides, fire breakouts, glacier break. If in the areas of Himalaya, if the earthquake is occurring, and sometimes the glaciers they will break and they will start rolling down, and because of that you may have the floods also. Then groundwater gets affected. The quality of groundwater gets affected because of the earthquake, because a lot of destruction will take place, a lot of things will happen below the ground, and because of that some amount of parameters they will change, like total dissolved solids, or maybe sometimes the selenium gets released, radon gas gets released because of the earthquake activity, and suddenly the content of these parameters will increase in the groundwater. Then earthquakes may lead to the diseases also. So if the earthquake is there and the rainfall is there, and because of the worst situation in that earthquake affected areas, some diseases will occur, and lack of basic necessities will be there. So these are the negative impacts of the earthquakes. Here you can see some of the photographs of earthquakes in India. Here you can see the Indian Ocean tsunami, which occurred on 26th of December 2004. Here you can see this is caused because of the Indonesia earthquake. Here you can see this is the picture after 1 hour. Here is the epicenter, and this much area is traveled by tsunamis. After 2 years, after 2 hours, almost it is touching the eastern coast of India. Here you can see after 3 hours, almost complete eastern coast got affected, and this is after 4 hours. So the tsunamis, they will travel very fast, and they can cover hundreds of kilometers distance within few minutes. So this is how the tsunami, they have hit the eastern coast and some part of the southern tip of India, and slightly some part of western coast also got damaged because of these tsunamis. Here you can see the tsunami they have hit. These are the tsunamis. These are the big waves. This is the Marina Beach after the tsunami. This is the Vivekananda Rock Memorial situated at the southern tip of Kanyakumari. See, these are the tsunami waves, how big these waves are. These are tsunamis in Thailand. In the Thailand also, that Indonesian earthquake has caused tsunamis, and they have affected many areas from many countries. This is from the Thailand. Then houses, they were crashed because of the earthquake, because of the tsunamis. Roads were crashed. So can earthquakes be predicted? So earthquake prediction program is there, which includes the laboratory and field studies of rocks before, during, and after the earthquakes. And monitoring activities, they are also going on continuously along the major faults. And the people or scientists, they are producing the risk assessment, they are carrying out risk assessment, they are preparing the hazard zonation maps. But earthquake prediction is very difficult because it is a sudden disaster, and it is not possible. Only once the China could predict one earthquake till today before few minutes. The prediction techniques, what are the prediction techniques they study? The seismicity pattern, how is the seismicity of that particular area, what is the electromagnetic field, what is the ground movement, what are the weather conditions, and unusual clouds if they are coming, what is the radon content of the and hydrogen gas content of the soil and groundwater. As I told you before the earthquake,
सर आवाज येत नाहीये.
आता येतोय का?
हो सर आता येतोय.
Okay. So if you wait for earthquake to occur, you are too late. So always keep the following in a designated place: bottled drinking water, non-perishable food, first aid kit, torchlight, battery-operated radio, and extra batteries. And teach the family members how to how to turn off the electricity, how to turn off the gas, and how to run away or out of the house. So these are the things which you should tell to your family members if you are staying in the earthquake prone areas. Then identify the places in the house that can provide the cover during an earthquake. It may be easier to make a long distance calls. So when you are identifying the places, generally you should use the door frames. You should not stay just next to the cupboards, because on the cupboards generally we keep some of the things, and during the shaking because of the earthquake, the things which are on the cupboard, they may fall and they may do injury to your head. So that's why you should be staying away from the such places. Like you should be away from the windows also, because if you have the big earthquake, then the glasses they may break and it may cause the injury. So you have to identify the places in the house, because during the earthquake immediately you cannot run. Because if you are at the ground floor, yes, you can come out. But if you are on the higher in the higher buildings, on the higher floors, so immediately it will be very difficult to run also. So that time you have to sit in the house only, stay in the house only for some time. It may be easier to make long distance calls during an earthquake. So identify an out of town relatives, friends, and for the emergency, and you can give the news to them that such thing has happened. Then safeguard your house. Consider the retrofitting your house with the earthquake safety measures. There are building codes are there. If you see the Koina earthquake and Latur earthquake, the magnitude was almost same, but the death at Kilari was huge, more than 10,000. That is the official government figure. In fact, more than that, the deaths have occurred because of the poor construction of the house. Reinforcing the foundation and frame could make you house quake resistance. Nowadays, in the earthquake prone areas, the contractors or builders, they will go for this earthquake resistance houses, proper RCC structure they will construct. And you may consult a reputed contractor and follow the building codes for if you are constructing on your own. Then during the earthquake gives no warning at all. As I told you, sometimes a loud rumbling sound might signal its arrival. Sometimes subterranean sound or rumbling sound will be there, but not always. Just a few seconds ahead of a time. Those few seconds could give you a chance to move to a safer location. Here are some tips for keeping safe during earthquake. Take a cover, go under the table or other sturdy furniture. Maybe table is there. Sit below the table, kneel or sit down or stay close to the floor. Hold on the furniture legs for the balance. Be prepared to move if your cover moves. If no study cover is nearby, kneel or sit close to the floor next to a structurally sound interior wall. Place your hands on the floor for the balance. Do not stand in doorways. Violent motion could cause doors to slam. and cause a serious injuries. You may also be hit by flying objects. Move away from the windows, mirrors, bookcases, and other unsecured heavy objects. If you are in bed, stay there and cover yourself with pillows and blankets. Your head should be intact. Do not run outside if you are inside. Never use the lift. If you are living in a kacha house, the best thing is to move to an open area where there are no trees, no electric poles, no telephone wires. These are the safety measures. Don't use the lift, use the staircases, go under the table, kneel down and protect your head. Okay, so such things you can. If you are driving a car, then avoid the bridges, avoid the poles, and stay away from the utility wires also. Don't get panic. Find a way to go out. Where is the exit? Keep the distance from the buildings. Go to the assembly point. Nowadays, the big buildings, they provide the assembly point in any type of disasters. So, and there you can gather during the disaster, maybe fire, maybe earthquake, or maybe other disaster. Here you can see the Japan earthquake resistant dome houses. They are not tall, they are dome houses, or they are using such type of wood material so that even if it collapse, more injury will not be there. Here you can see normal. This is a normal building. In the earthquake, as I told you, the waves will come from one side and it will go to other side. That time the house will get, it will have the shaking front side and back side, front side, forward and backward. Shaking of our building will be there. So in the Japan, now what they have done at the base, they have put the sensors, and on the top of the buildings, they have the weights. And based upon the movement of the house, suppose the house is moving on the right side, the weight will move on the left side so that it will balance and the collapsing of building will not be there. Such buildings are there in the Japan because Japan is experiencing many earthquakes, quite frequent earthquakes and huge earthquakes. So these are the 7 steps to earthquake safety. Secure your space by identifying the hazards and securing the movable items. Plan to be safe by creating your emergency plan and deciding how you will communicate. Organize emergency supplies in convenient locations. Minimize financial hardships. Then drop, cover, and hold on or other recommended actions if you feel. Step 6 is improve safety after the earthquake by evacuating if necessary, helping the injured one, and preventing the further injuries or damage. And 7 step is reconnect and restore the daily life by reuniting with others, repairing damage, and rebuilding the community. If you are outdoors, move into the open areas away from the building, street lights, and utility wires. Once in the open area, stay there until the shaking stops. If your home is badly damaged, you will have to leave, collect water, food, medicine, other essential items, and important documents before leaving the house. Avoid places where there are loose electric wires and do not touch metal objects that are in touch with the loose wires. Do not re-enter damaged buildings and stay away from badly damaged structures. Move to the clear area. If you are moving in a vehicle, move to the clear area away from the buildings, trees, overpasses, or utility wires. Stop and stay in the vehicle. Once the shaking has stopped, proceed with caution. Avoid the bridges or ramps that might have been damaged by the earthquakes. After the earthquakes, wear shoes and chappals to protect your feet from the debris because in the debris, you may have the metals, wires, and glass pieces that will injure your feet. After first tremor, be prepared for aftershocks. Aftershocks can occur in the first hour, days, weeks, and even month after the quake. Check the fire hazard and use torch lights instead of the candles or lanterns. If the building you live in is in good shape after the earthquake, stay inside and listen to radio advices. Do not touch downed power line. Help the injured persons. Give first aid where it is appropriate. Do not move seriously injured persons unless they are in immediate danger of further injury. In such cases, call for the help. Remember to help your neighbors who may require special assistance, infants, small children, the elderly ones, and people with disabilities. Listen to battery operated radio for the latest emergency information. Stay out of damaged buildings. Return home only when the authorities say it is safe. Your home is safe. Clean up spilled medicines, bleaches, and gasolines and other flammable liquids immediately. Leave the area if you smell gas or fumes from the other chemicals. Open closet and cupboard doors cautiously. If you smell gas or hearing hissing noise, open the windows and quickly leave the building. Turn off the switches on the top of the gas cylinder. Look for the electric system damages. If you see the sparks, broken wires, if you smell any burning, then turn off the electricity from the main fuse box. If you have to step in water to get the fuse box, call an electrician first for the advice. Check for the sewage and water lines damage. If you suspect sewage lines are damaged, avoid using the toilets. If the water pipes are damaged, avoid using the water from the tap. Use the telephones only for the emergency calls. In case family members are separated from one another during an earthquake, then develop a plan for the reuniting after the disaster. And be smart about the earthquake safety, and accordingly you do your actions. The next disaster is the landslide. A landslide, also known as a landslip, it is a geological phenomena again that includes a wide range of ground movements such as rockfall, deep failure of slopes, and shallow debris flows. Landslide can occur in offshore, coastal, and offshore environments, although the action of gravity is the primary driving force for landslide to occur. There are other contributing factors affecting the original slope stability. So, in simple words, landslide is a downward movement of the rock, of the soil, or vegetation under the influence of gravity. Gravity is the main cause. So, what is the safety factor? The factor of safety is defined as F is equal to resisting force R divided by driving force D. Here you can see the diagram. This is the slope. Resisting force is shown by this arrow, which is going in the upward line. This is resisting force. And the downward, this is the driving force. So if F is less than 1, landslide will occur. When you will have F less than 1, if the driving force is more than resisting force. If this force is more than the resisting force, that time the F factor will be less than 1. So during that, the landslide will occur. And if the F factor is greater than 1, landslide will not occur. So role of gravity and the slope angle. The gravitational force acts to hold the objects in a place by pulling on them in a direction perpendicular to the surface. You have two stress, shear stress and normal stress. Shear stress is the downslope component of the total stress involved. Steepening a slope by erosion, jolting it by earthquake, or shaking it by blasting can cause an increase in shear stress. And normal stress is the perpendicular component. Here you can see this is the shear stress and this is the normal stress. As I told you, the safety factor, if it is less than 1, then it is unsafe, unstable. So driving and resisting forces determined by the interrelationship of the following variables: type of earth material, what is the slope angle, and what is the topography, what is the climate, what is the vegetation, what is the water, what is the time. So these are the factors. They will be responsible for the driving and resisting forces. This is the landslide zonation map of India. Here you can see the northern and northeastern India is prone to the landslides, and Western Ghat and some portion of the eastern coast is vulnerable for the landslides. This is the classification of earth movement. Generally, we say the landslide, but in geological term, they are called as the earth movements. And these earth movements, they are classified into earth flow, landslide, and subsidence. Earth flow includes solifluction, creep, and rapid flows. And landslides include debris slide or slump, rockfall, and rock slide. And subsidence includes plastic flow and collapse. This is a solifluction. It is a downward movement of a wet soil. It is called as a solifluction. Soil creep. It is the downward movement of a dry soil material or soil matter. Movement of the soil occurs in the regions which are subjected to freezing and thawing action. In the freezing, the contraction will take place. In thawing, expansion will take place. And because of that freezing and thawing action, the earth surface will become loose and it will come down. That is the soil creep. Then rapid flows is similar to the creep but differs in terms of the speed and depth. It is a faster. And creep is involved up to shallow depths, up to 1 to 2 meter. But whereas the rapid flow involved to a greater depth, up to 5 meters also. And the landslide. If a mass of earth moves along a definite plane, this is the plane or the surface along which the failure has occurred. This is the landslide. So large blocks known as slump block moves during the landslide. And the scar above landslide is easily visible. Here you can see the scar of the landslide. They occur along a slope where the internal resistance of the rocks are reduced or they lose their holding capacity. It is common after the earthquakes or after removal of the part of the slope due to construction, particularly for the construction of the roads. Here you can see this is the road. Then you have the debris flow. They have the failure of the unconsolidated material on the surface, rockfall or rock slide, movement of a large rock blocks which are coming and rolling down. That is because of the poor water pressure is the key. Here you can see this is the debris flow and this is the rock flow. And the talus, that is nothing but this accumulation of the rock fragment material. Accumulation formed by the coarser rock fragments resulted from the mechanical weathering along the slope under the influence of gravity. Here you can see this is the talus material. Then subsidence. Subsidence occurs due to plastic flow. It may occur when plastic layer like a clay bed is squeezed outward due to overlying heavy load. So below you have the clay bed and that is squeezed because of the overburden. Then you have the plastic flow. And subsidence due to collapse, it occurs due to the extensive pull of large volumes of underground water due to subsurface solution activity in limestone terrace. Here you can see this is a subsurface activity, and this is the leaning tower of Pisa, Italy, the tilting of which accelerated as groundwater was withdrawn from the aquifers to supply the growing city. So a lot of overpumping, overdrafting of groundwater was there from the aquifers, from the wells, and because of that, the pore pressure was reduced, and because of that, the tilting has taken place. Now some measures have taken place and completely the drafting or withdrawn of water is completely stopped. So these are the causes of landslide: natural factors, that is gravity, and geological factors like what type of rock is there, where the impermeable, permeable layers are there or not. Then heavy and prolonged rainfall and earthquakes. So these are the causes of landslides. Influence of slope. So what is the slope angle? It varies from 30° for unconsolidated sediments. If the loose material is there, then 30° is enough for to occur the landslide. So 30° to 90° for massive rocks. If the rock is massive, compact, without joint, then 90° slope is there, then also you will not have the landslide. And if the rock is partly jointed or fractured, then 60 to 90° angle is enough. You will have the landslide if it exceeds. Then groundwater or associated water. Main factor responsible for slippage is, suppose the hard and massive rocks are underlain by softer rocks, shale or clay beds. And when rainfall occurs, that time the water will percolate down and it will go to the softer rock area. And this acts as a slippery base because of the interaction with the water. And then the upper material will come down and landslide will occur. Then what is the lithology? Rock with rich clay, mica, calcite, gypsum, they are prone to the landslide because these minerals are prone to the weathering. Then what are the geological structures present in that rock? Occurrence of inclined bed, if joints are there, faults are there, shear zones are there. These are the zones of the weakness. If these are present in the rock mass, then you will have the instability of the slope and the landslide will occur. Then human influence, undercutting along the hill slopes for the laying the roads, for laying the rail tracks. This can result into the instability of the slope. Then deforestation in the upland areas. This will result into the more erosion during the rainy season. Soil will come down and the holding capacity of the earth surface will be reduced because the plant roots, they hold the land together. And if the deforestation occurs, then the slope becomes unstable and landslide will occur. And what are the external factors which are responsible for landslide? Most common factor is the vibration, and that vibration has resulted maybe because of the earthquake, maybe because of the blasting, or maybe because of the volcanic eruption. Here is the example. In the year 1897, Assam earthquake produced gigantic landslide ever recorded in that region. Role of water is very, very important. As I told you, if you have unconsolidated sediments and if the rainfall is more in that particular area, then you may have the landslide. Generally, in the Western Ghats, because of the rainfall, that soil which is composed of sand, silt, and clay becomes saturated with water, and the fluid pressure of this water rises above the critical limit, and the fine-grained sediments they will lose the strength and they begin to flow in the downward direction. So what are the preventive measures you can take? The main factor which contribute to landslide are the slope, water content, geological structure, unconsolidated or loose sediments, lithology, vegetation cover, and human interference. So for the slope, retaining wall may be constructed against the slopes, which can prevent the rolling down of the material. Terracing of the slope is an effective measure. Then effect of water, make the proper drainage so that water will not percolate down through the fractures and joints, and so that it will not damage the lower part of the earth surface. Then geological structure, weaker planes, zones may be covered or grouted. Suppose fractures, joints are there, then you can put the cement into these fractures and joints so that the further damage will not take place. Then the damage landslide will destroy the complete slope of the hills. It eliminates all the vegetation during the landslide. All the vegetation will also come along with the earth's material. It buries the houses and sometimes entire village also. We know the example of Malin. Complete village was buried under the landslide, and it weakens the slope and makes it more susceptible for further landslide. If you do not do the precautionary measures, preventive measures in the already landslide area, then again in the next year, in the next rainy season, you may have the landslide in the same location. Here you can see the complete landslide has destroyed the railway track also. Here you can see this is the situation generally we see when we travel from Pune to Mumbai in the Ghat section. This is the location of the Marine village where complete village was buried under the landslide earth material. Then how to minimize the landslide hazard? Identifying the potential landslides. You can do the photographic analysis, aerial photographs, you can use topographic maps, you can use it, and you can do some field check also, and you can use the historical data also. And then you can identify the landslide potential areas or landslide prone areas where the vulnerability is more, medium, or low. Then you can prepare the landslide hazard inventory map, and you can give the different codes also from least stable area to the most stable area. Then you can do the hazard mapping. You can study the land use pattern in that particular area. You can put the retaining walls as a mitigation measure. Then you can improve the surface drainage. Then you can have the engineer structures. Sometimes big walls on the small streams, they are essential. You can increase the vegetation cover in the deforested area so that the land will become, or the earth surface will become stable, because the roots, they will hold up the earth surface. And you can go for the insurance policies also. So this is the news from the Mumbai area. 74 areas are prone to the landslide. This is the map of the area. Here you can see. And year-wise, from 2013 to 2018, how many landslides have occurred? In the red color, these are the vulnerable areas, and the blue one, these are the dangerous areas. And again here, you can use the remote sensing also, as I explained you in the earlier lecture also. So for all types of disaster, you can use the remote sensing data, topographic map, maybe some demographic maps are there, land use, land cover maps, you can use it. And combinedly, you can prepare the hazard zonation map, where you can give the different codes, or even if you simply, you can make low prone area, medium prone area, and high prone areas. And then in the high prone areas and middle medium prone areas, you should conduct some trainings for the people, how to prepare for the hazard and how to minimize the impact of the hazard. Such type of training you can give to the people, so that the loss of life and loss of property will be reduced after the disaster or during the disasters. So this is all from my side. Thank you very much. If there are any questions, then you can ask me. Hello? Hello, any question is there? Hello?
Sir, I have pasted my question in chat box.
Okay. Is it true that birds and animals can imagine or detect earthquake before it occurs? This is your question? Is it true that birds and animals can imagine
Or detect.
or detect? Okay. Yeah, I told you in the lecture itself that animal, if you observe the animal behavior, those animals who are staying in the below the ground in the holes, because before the earthquake, slightly the temperature of the ground will be increasing, and these animals, they are very very sensitive. They will sense that and they will come out of the hole. So if you observe the animal behavior, yes, you can predict that. Any other question?
Is there any question, participants?
If there are no questions, then I can leave the meeting. Just tell me.
No, sir. Just wait for vote of thanks, sir. Please.
Okay, okay, okay.
Okay, may I propose vote of thanks, dear all?
All the participants, they have muted their mics.
I presume that there is no question, sir. And I propose the vote of thanks.
Okay, okay.
Yes. Respected dignitaries, esteemed guests, and dear participants, it is with a great honor and gratitude that I extend the heartfelt vote of thanks to Dr. Dipak V. Panaskar, sir, Senior Retired Professor and former Director, BCUD School of Earth Science and School of Interdisciplinary Studies, Swami Ramanand Tirth Marathwada, University Nanded, for his enlightening and thought-provoking lecture on disaster management. During this online refresher course organized by Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Shivaji Nagar, and UGC Malviya Mission, teachers.
Okay, thank you very much for patience listening. Hello? Hello, sir.
Yes, hello.
Good.
हाँ सर.
हाँ.
हॅलो.
हो हो, चालेल चालेल, ओके. हो ना, तेच ना.
Excuse me, Gaurav sir.
Yes, sir. Oh,
May I continue with my vote of thanks, sir?
any question, participant? Please आप
No,
unmute
no,
कर
no, no,
सकते
sir.
हैं.
Question answer session is over, sir. Now I am
सर किसकी कोई क्वेश्चन है क्या?
हॅलो सर. हॅलो
Hello.
हॅलो.
Yes.
सरांना एक प्रश्न विचारायचा होता.
विचारा.
तर भूस्खलन जे होत आहे तर
हा.
त्याआधी काही आपल्याला काही असा इशारा वगैरे मिळण्यासाठी अशी काही सुविधा वगैरे उपलब्ध आहे का, काही असे यंत्र वगैरे की इथे असं काही होऊ शकतं, जसं आपण GPS वगैरेच्या माध्यमातून माहिती मिळू शकतो, GISच्या माध्यमातून. तर असं भूस्खलनाच्या संदर्भात काही आहे का?
भूस्खलनाच्या संदर्भात फक्त हझार्ड झोनेशन मॅप्स वगैरे वापरून काही मॅप्स तयार झालेले आहेत, हझार्ड झोनेशन मॅप्स. त्याचा स्टडी करावा लागेल आणि समजा त्या एरियामध्ये लँडस्लाईडला बेसिकली कसं आहे, खूप सारा पाऊस लागतो, कंटिन्युअस पाऊस. समजा 4-5 दिवस हेवी रेनफॉल जर असेल तर त्या ठिकाणी शक्यता ही बळावते. आणि समजा कारण वॉटर इज द मेन कल्प्रिट फॉर दॅट, कारण त्यांनी स्लिपरी बेस तयार होतो आणि लँडस्लाईड होते. म्हणून ज्या ठिकाणी हेवी रेनफॉल आहेत त्या एरियामध्ये दरवर्षी बिफोर द रेन थोडंसं मॉनिटरिंग केलं पाहिजे. कुठला एरिया थोडंसं काही साईड पोर्शन हे झालंय का, किंवा झाडं जी असतात स्लोपवरचे ते झाडं थोडीशी तिरकी होतात. झाडं तिरकी होतात म्हणजे तिथं थोडीशी मुवमेंट अशी सुरू आहे आणि मग जास्त पाऊस पडला की निश्चितच त्या ठिकाणी लँडस्लाईड होऊ शकते.
थँक्यू सर.
ओके. मला वाटतं प्रश्न नाही आहेत कोणाचे.
Okay, Gaurav sir, may I proceed with my vote of thanks?
Yes, sir.
Okay, thank you, sir. Respected dignitaries, esteemed guests, and dear participants, it is with a great honor and gratitude that I extend my heartfelt vote of thanks to Dr. Dipak B. Panaskar, sir, Senior Retired Professor and former Director, BCUD School of Earth Science and School of Interdisciplinary Studies, Swami Ramanand Tirth Marathwada University, for his enlightening and thought-provoking lecture on disaster management during this online refresher course organized by Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar, and UGC Malviya Mission Training Center. Dr. Panaskar's session provide us with a deep understanding of the type of disaster, emergency management, precautionary measures before and after the disaster, as well as the effective planning and rehabilitation strategies. These insights not only enhanced our knowledge of disaster management, but also introduced us with a new crucial concepts. One of the term that stood out of me was the psychological disaster. Learning about the psychological impact of disaster and the need of the mental health intervention has added a new dimension to my understanding of disaster management. Moreover, the second hour interactive session was incredibly enriching, where Dr. Panaskar sir elaborated the earthquake and as a natural disaster and provided the valuable insights on equipments of measuring earthquakes, including the seismograph and how to interpret the seismograph readings, the different waves of the earthquake and how they travel through the earth's layer, the elastic rebound theory explaining how the stress build up and released to earthquake. This such kind of a valuable knowledge has provided to us on behalf of organizing committee, the faculty members, and all the participants. I express my sincere gratitude to Dr. Panaskar sir for sharing his valuable time, knowledge, and wisdom to us. I also express my thanks to UGC Malviya Mission Teachers Training Center, Dr. Babasaheb Ambedkar Marathwada University for organizing such an essential refresher course. A special note to appreciation goes to all the participants whose enthusiasm and engagement made this session even more meaningful. Once again, a big thank to our Dr. Panaskar sir for his valuable contribution to our learning. Thank you, sir. Thank you very much.
Yes, thank you very much. I am very much thankful to Dr. Chauhan sir and Dr. Patil sir for giving me this opportunity to interact with you. Thank you very much.
It is our pleasure, sir.
Thank you.
It is our pleasure. And thank you for sparing your valuable time. Thank you very much.
Okay.
Thank you, sir.
Shall I leave the meeting?
Yes, sir. Yes, sir. Sure.